Mechanical characterization of wood apple shell powder and tamarind shell powder reinforced with epoxy resin. Abstract: in this work, variation of tensile compression and impact test of the tamarind shell and wood shell particulate composites was studied. From experimental results, it is found that composites prepared with 25% of WAS and 5% TS powder reinforced epoxy composites exhibited better tensile, compression and flexural properties as compared to 0% plus 30%, 5% plus 25%, 10% plus 20%, and 15% plus 15% combinations. For impact studies, all samples have exhibited the same amount of energy absorptions for all combinations. This study reveals that drop in the mechanical properties for the 30% was plus 0% TS composites and slight increment in the mechanical properties for increase in the TS percentage with the WAS. Keywords: epoxy resin, hardener, tamarind shell powder, tamarind shell powder. 1. Introduction. The engineering importance of a composite material is that two or more distinctly different materials combine to form a composite material that possesses properties that are superior to those of the individual materials. A simple example of a composite is the plywood. A plywood is a wood product out of many sheets of wood veneer, pressed together and glued. When layers like this are put together, it produces a very sturdy and durable wood. Plywood is used instead of plain wood because of its resistance to cracking, shrinkage and its general high degree of strength. 2. Materials and methodology. 2.2 Wood apple shell powder. 2.3 Matrix system. 2.1 Tamarind shell powder. Figure 2.1.1 Tamarind shell powder. Tamarind is one of the very developed trees in India. Truth be told, India is one of the most astounding cultivators of tamarind on the planet. Tamarind comprises of 3 sections: tamarind organic product mash, which is palatable, hard green natural product mash, and tamarind seed. Tamarind organic product test powder, commonly known as tamarind shell powder, TSP. Figure 2.2.1 Wood apple shell powder. The wood apple shell was dried and outside and granulated into powder utilizing a pummeling machine. The powder was sieved as per BS 1377:1998 standard. The compound investigation of the wood apple shell was finished with absorption spectrometer, AAS, Peck and Rudder 2006 model. The molecule size utilized was 280 m. 2.3.1 Epoxy resin, L12. Figure 2.3.1.1 Epoxy resin, L12. Epoxy L12 is a fluid, unmodified epoxy sap of medium thickness which can be utilized with different hardeners for making glass fiber fortified composites. 2.3.2 Hardener, K6. Figure 2.3.2.1 Hardener, K6. Hardener K6 is a low consistency room temperature restoring fluid hardener. It is normally utilized for hand layup applications. Being fairly responsive, it gives a short pot life and fast fix at ordinary encompassing temperatures. 2.4 Procedure for particulate composite plates. Methodology. 3 Size of particulate composites. 5.1 Tensile test. A form of size 280 mm x 150 mm x 6 mm was set up of hardened steel for getting ready plate tests. Form comprises of a base plate, outline that could be destroyed to encourage simple evacuation of throwing after the restoring. Every one of the surfaces of the form were covered with wax. All the internal surfaces of shape, interacting with surfaces of composite to be cast, are spread with uniform covering of wax so as to encourage the arrival of the cast piece. Volume equals length x breadth x height. Volume equals 280 x 150 x 6. Volume equals 252,000 mm2. Equals 252 cubic centimeters. In this study, effect of variation of WAS and TS powders were carried out and the results were discussed below for tensile, compression and flexural tests. 5 Results and discussions. The tensile tests were conducted with respect to last meld 3039-76 standards in a universal testing machine. 6 Conclusions. The variation of tensile, bending and harness properties of the tamarind shell and wood apple shell particulate composites was studied. From experimental results, it is found that composites prepared with 25% of WAS and 5% TS powder reinforce epoxy composites exhibited better tensile, compression and flexural properties as compared to 30% plus 0%, 20% plus 10% and 15% plus 15% combinations. For impact studies, all samples have exhibited the same amount of energy absorption, i.e. 2 joules, for all combinations. This study reveals that drop in the mechanical properties for the 30% was plus 0% TS composites and slight increment in the mechanical properties for increase in the TS percentage with the WAS.